Welcome. Thanks for joining us today. I'm Lou Ann Dahlman. I'll be facilitating today's NOAA Climate Connection webinar. We present this series in collaboration with the National Weather Service Climate Services Division. Our collective goal is to help NOAA personnel and partners find and use the climate information they need. During today's presentation, attendees will be in listen-only mode. If you have questions or comments, we invite you to type them into the questions pane of the GoToWebinar control panel. At the end, I'll ask our presenters to respond to as many of them as they can. Today, we're going to hear about the possible connections between warming in the Arctic and mid-latitude weather patterns. Content comes from discussions by experts at a National Research Council workshop in September of 2013. Katie Thomas of the National Academies Board on Atmospheric Sciences and Climate served as the study director. She'll speak to us first. Following her presentation, we'll hear from David Robinson, New Jersey State climatologist and director of the Global Snow Lab at Rutgers University. Dave chaired the workshop committee. The culmination of that workshop is a publication entitled Linkages Between Arctic Warming and Mid-Latitude Weather Patterns, Summary of a Workshop. Thank you for starting, Katie.
Thank you, Lou Ann. Thanks to NOAA as well for giving us the opportunity to discuss some of the key messages from our report. So Dave and I are going to split the presentation today. I'm going to start off by giving some background on the National Academy of Sciences for those of you on the line who may not be familiar with us. And I'll give a little bit of context on the topic of the report and some of the key messages from the big picture context. And then Dave will discuss the observations of Arctic linkages and some of the modeling work that has been done. So who are the National Academies? We are a nonprofit organization established under the Lincoln administration in 1863. And we are charged to provide independent advice to the nation on science, engineering, and medicine. And we're a private nonprofit. We are not a government agency. And then under this umbrella of the National Academies, we have the National Academy of Engineering and the Institute of Medicine. And to complicate things further, we also have the National Research Council, which is considered the operating arm. This is where our committee reports and committees come from. So study requests typically come from federal agencies, but occasionally they'll come from Congress, state agencies, and foundations. And sometimes we also have internally generated projects, and in fact the one that we're going to talk about today was generated from the two boards. And our intellectual leadership comes from volunteer committee members who are chosen for their expertise and their objectivity. And when we put these committees together, we do spend quite a bit of time ensuring that they're appropriately balanced. We're most well known for our committee consensus reports. In fact, we released more than 200 a year. And these do everything from kind of assessing the state of the science. They provide consensus on science controversies. Occasionally we'll do independent peer reviews of documents or programs. But we also hold workshops, research grants, and fellowships. And so under the National Research Council lie numerous boards that are topically organized. And the two boards that were involved with this project are the Board in Atmospheric Sciences and Climate and the Polar Research Board. And BASC, their interests lie in weather and climate science, the composition of the atmosphere, including air pollution. And I've included here some of our recently released reports. Our most recent one is the Abrupt Impacts of Climate Change. And in this report, the committee assesses the likelihood of potential abrupt changes to the ocean, atmosphere, ecosystems, and high latitude areas. We've recently held a workshop on urban forestry and some of the ecosystem services, and we've done one on urban meteorology where we've tried to better understand how we can meet end user needs. And then the PRB, they provide independent advice to federal agencies on science issues, in the Arctic, Antarctic, and the cold regions in general. And they're kind of unique because they look both at the Arctic and the Antarctic, so they also try to foster coordination of research between the two poles. And so also here I've included some of their recent reports. The most recent one is the Arctic and the Anthropocene. And in this report, the committee identified some emerging research questions that are important for understanding how environmental and societal transitions will affect the Arctic and the rest of the world. And we also held a workshop last year on how we can use remote sensing in innovative ways to better understand permafrost. So getting to the report we're going to talk about today, just to provide a little bit of context, as I'm sure many people are aware, the Arctic has been undergoing significant changes in the past 10, 15 years. Surface temperatures are rising 2 times faster than the global mean. The extent and the thickness of sea ice is rapidly declining. So you can see this on the graph on the slide from the National Snow and Ice Data Center. It's a little bit hard to see, but that black line is the 1981-2010 average of sea ice extent, and then the lines below that are individual years dating back to 2007, and you can see those they are all significantly below the mean. And in addition to the loss of sea ice, snow cover in the Arctic is also declining. In this figure, this map here shows June 2012 snow cover anomalies relative to the 1971-2000 average. And the brown are areas that are where they've experienced a decline in snow cover, so you can see that's pretty vast in the Arctic. And at the same time we've been experiencing these changes in the Arctic, there's been a series of record-breaking extreme events taking place around the world in the past 10 years. And in this map, this shows some of those, everything from hurricanes to tornado outbreaks and droughts. And some of these have been high profile and high impact. So, for example, Hurricane Sandy. And in 2011, there were 14 events that totaled more than $1 billion each. So this has prompted some scientists to question whether these changes we've been experiencing in the Arctic are somehow impacting atmospheric conditions outside of the region. And so this slide, I'm not going to go through all of these, but these are just some of the hypotheses that have been proposed that link Arctic sea ice loss and Arctic warming to changes in mid-latitude weather patterns. And the takeaway here is some of these have received more attention than others. So, for example, this first one listed here from Francis and Vavris that's received quite a bit of attention. But there have been several hypotheses proposed, and this is a really active and recent area of research. You can see from the citations there. In fact, when we were working on this, it seemed like there was a new paper coming out on this topic every few weeks. So the two boards felt like, given that this is such an active area of research, it might be an interesting topic for a workshop. So we put together a small NRC committee to organize the workshop. And from the beginning, they really felt like the goal shouldn't be to come to consensus on these issues. Rather, we should bring together a diverse array of experts and perspectives to explore these issues, review our current understanding, and also identify some research needs to better understand proposed linkages. And the committee felt like it was important to take a global perspective and consider the influence of the Arctic in the context of forcing from other components of the climate system. So, for example, changes in the tropics, ocean circulation, and mid-latitude sea surface temperature. And then in March, we released a summary of the workshop discussions. And it's important to note that the summary doesn't have any formal findings, conclusions, or recommendations. It really is just an account of the workshop discussions. And it's not meant to be comprehensive because we are limited to only including what was discussed at the workshop. Even though the committee was not involved in the writing of the report, it was peer-reviewed. And so these are just some of the folks that were involved in this project. On the left, you see the roster of the organizing committee who plans the workshop. On the right-hand side are our speakers who gave formal remarks at the workshop. But we did also have an additional 20 people who participated in the workshop. And then on the bottom of the screen are the reviewers of the report. And you'll see there's a little bit of overlap. Cecilia Vitz, not only did she serve on the planning committee, but she also served as a reviewer. And a couple of the reviewers did attend the workshop as well. And when I put this report together, I really did try to keep the same structure that the committee worked on for the agenda. And we had 3 plenary sessions. The first one, again, going back to this big picture global context. The second session, we discussed some observational evidence of these proposed linkages. And then the third session, we discussed modeling work to test some of the mechanisms. And a neat thing about this workshop is the committee had open panel sessions after each of the 3 plenary sessions where anyone could come up and present a couple slides and speak for a couple minutes, whether it was their own work or a colleague's work, just as long as it was related to the topic, of course. And it was a nice way to ensure that everyone had a voice at the table and an opportunity to speak. And then to finish up the workshop, we held breakout group sessions to discuss future research needs. And I should note that in the appendix of the report, we have abstracts of all of the presentations, including the ones from the open panel session. And the PowerPoint slides are also on our website, which we'll show at the end of today's presentation. So getting to some of the key messages from the workshop, from this first session on the big picture, it was clear that there are some complex mechanisms and feedbacks that link the tropics, the poles, and the mid-latitudes. And the participants noted that these feedbacks and mechanisms can be bidirectional and are not necessarily direct. So, for example, the stratosphere and the ocean may act as an intermediary. Participants also felt like understanding how Arctic warming could impact these linkages or other large-scale circulation patterns is critical, but the large natural variability of the atmosphere and the Arctic sea ice makes attribution difficult. So this figure here was put together by the big picture speakers, James Green, Libby Barnes, and Paul Kushner. And I think it does a really nice job of highlighting the complexity and the interconnectedness of the climate system. So you see they have the role of the ocean, modes of variability, snow, stratosphere. They'll be the first to admit that this isn't perfect and you don't want to get too caught up in the details, but I think it does do a nice job highlighting all of the players here. And then another key message to emerge from the session is even if you think back to the earlier slide showing all of those proposed linkages, these linkages are just not a point A to point B. They're composed of several steps. And this is complicated because each of these steps has inconsistent evidence from observations and modeling studies. And so I'll turn it over to Dave Robinson now to talk a little bit about the observations and modeling work.
Okay, great. Thanks, Katie and Luann. Pleasure to be here to sort of sort through a very complex subject. I think the figure 2 slides back that Katie shows kind of spells things out, but everyone listening appreciates the complexity of the climate system. And here we're trying to link together possible connections between the poles and the middle latitudes. And as Katie mentioned earlier, we can't forget the tropics as well, as some of the participants and subsequent discussion of this since the meeting will not let us forget that there are tropics acting on both the middle latitudes and the high latitudes as well. So what these next few slides, a lot of words on these slides, and I really recommend you read the excellent report that Katie put together to get to some of the details. But the whole purpose of this workshop was just to look at the state of where we were with the observational evidence, with the modeling, and of course kicking it off and really concluding with a look at the big picture. So first, looking at observational evidence, you can see this bulleted list of all the different factors or features or variables within the atmosphere, ocean atmosphere system we wanted to look at. The fact that it's relatively well understood that the Arctic is warming, and it's warming at a faster rate than the remainder of the northern hemisphere, or the globe for that matter. And with that, you'll have a decreased temperature gradient between the Arctic and the middle latitudes. But then it becomes a little trickier in terms of whether this should affect the upper level zonal winds, whether it should become a more wavy meridional wind pattern, a wavier jet stream, whether there should be a greater amplitude with those waves, of course, and whether there may be more blocking associated with that in the subpolar or polar latitudes, and then the progression of these waves. And then with that, the potential for associated increases in extreme events as you put warm air where it is not commonly found, and likewise put cold air where it may not commonly be found, and at the boundary of the two, perhaps spawn some significant storms. And then the overall weakening of the polar vortex, which we were talking about before it became part of the national vernacular in this past winter. The next slide shows just an example of some of the evidence out there, some of the information out there. I want not even evidence, but just what we need to look at. And some of it is certainly contradictory at this point. We have to remember this is a work in progress. These are hypotheses, nested hypotheses that have been put forth by some, at times I'd have to say, brave scientists. And now there's a wealth of work, as Katie said, new literature coming out every week, it seems, addressing these hypotheses. For instance, here we can see some study of the decreasing upper level zonal winds with a weakening temperature gradient. Jim Oberlin has seen that, but then we see this pattern of observations back over 60 years. And you see that perhaps with this weakening of the winds associated somewhat with the decrease in ice extent in the Arctic, but likewise, or in the opposite sense, with the increasing wind speeds in the 50s to the 70s, we don't see a corresponding increase in sea ice cover. I should say we don't think we see it. As you go further back into the middle of the last century, our understanding of sea ice extent declines, obviously picking up as we got into the satellite era over the last 50 years. Next slide. Looks at the amplitude of Rossby waves. Here it's some results by Jennifer Francis suggest that there's been a change in the wave amplitude, and it's increasing, and in 3 of the 4 seasons in the northern hemisphere. But on the other hand, Screen and Simmons have found that there is a change in the spring, but not in the other seasons. And part of this is born, again, of different data records, perhaps different reanalysis data sets, and also sometimes just the definition of how one talks about meridionality. The next slide also speaks to that. So I think one thing that we need to do, and I'm jumping ahead a little bit, is come to some common agreement on how we're defining blocking, how we define meridionality, and so on, and zonal winds for that matter. But anyway, as it says here, we're not even in total agreement in the sign in some cases. Obviously, there are multiple candidates for mechanisms behind any change that we're observing. And there's the point I was starting to make. The method of measurement may be different. This may differ between scientists within polar scientists. It certainly can disagree between polar scientists and those perhaps studying in the tropics. And then there's even different definitions or different languages sometimes spoken by atmospheric scientists versus oceanographers. So that's certainly a suggestion of a way forward one way to start moving forward is to make sure we're all speaking somewhat of the same language. And then finally, patience. As climatologists, as humans, we're not very patient beings. But as climatologists, one would hope that we had more years of record. But in the case of the really dramatic changes in Arctic sea ice, it's mostly within the last decade, as for instance. Next slide. So what do? We do a lot of research. We need to have a number of different studies. We need to combine experts in dynamics, thermodynamics, tropics, polar regions. Let's not forget the middle latitudes, oceans, and atmosphere. It would be nice to extend observational records. There are some sea ice records that can be stitched together further back in time. There are efforts to pull together snow and ice climate data records. Stay tuned for that and look at the National Ice Center, but also at the National Snow and Ice Data Center, where I've led a team of scientists, and we're just finishing up a multi-year NASA-funded project to create an integrated snow and ice data set on a daily basis for the last 15 years and going back another 30 years, 20 years or so at a weekly time scale at high and standard resolutions. So that's the kind of thing we need to extend observational records, not only in time, but to integrate them between the ice on the oceans and the snow on the land. And then we just need to understand the atmospheric dynamics better in terms of blocking meridional winds and such. And I would say in some respects, all aspects of the hypotheses need testing. What may be a weak link to one is not a weak link to another, and vice versa. Next, we'll go on to the modeling side of the equation. There we go. So modeling studies, and this is really in its infancy as well, and it's just beginning. And I think it offers wonderful opportunities to do modeling, to better understand what we're seeing observationally, and be able to look into the future. First of all, the modeling studies can just offer mechanistic clues and see that things are coming in different directions, perhaps these different pathways, and look at external factors and such. So just those fundamental mechanistic studies, and then start forcing your models by changing the sea ice, or letting your models warm and then see what the resultant sea ice losses might be, and with those associated changes in all that bulleted list below, the temperature gradients, zonal winds, blocking, and just general weather patterns, and perhaps quite significantly storm tracks. Now there's just a recent paper out that tries to look at the Arctic in terms of whether it's storms are bringing in warmer air from the middle latitudes, or whether just the prevalence of more open water is enough to add a significant amount of warming to the Arctic internally or on its own. And in many of these cases, the first order answer is yes. They're both drivers. So we need to use modeling studies to understand and parse out how they may differ seasonally, sub-regionally, and then as we look into the future, over time. Next slide. Okay, this is just an example of some modeling that's been done using one particular scenario and looking ahead through the end of the 21st century, showing a flattening or a weakening of storm tracks equatorwards, shifting the storm tracks and their intensity further north. Just one possibility, as you have a larger Hadley cell as the middle latitudes warm, as your thermal gradients change. On the other hand, there's models that suggest that you may decrease cold extremes to the north, but actually, perhaps associated with increased meridionality, increase the intensity of cold periodically or aperiodically in more southerly latitudes of the northern hemisphere. Again, just modeling projections, just trying to understand where things might head as we go through the remainder of this century. Next slide. So the key message is, well, yeah, I mean, we have to look to models to better understand what the observations are showing us right now, to understand better mechanisms, and of course, look into the future. But there's a long way to go. Again, this is in its infancy. We're coupling land, ocean, and atmosphere models at this, but sometimes there may be a better looked at simpler models to understand particular mechanisms. So there needs to be a suite of modeling efforts addressing this very interesting topic, but not, I might add, speaking more as an observationalist, not at the expense of continuing a very rigorous monitoring program, not only in the Arctic, but of course elsewhere around the globe, not only from satellites, but from ships and buoys and field programs and continental-based station observations and radiosondes and you name it. So we need to really have complementary modeling and empirical studies. But I'm getting off topic. Let's go off the flow here. The next slide sums up, if it comes up. Looks like we've got a roadblock here. Okay. All right, so a way forward. Whoops. Can you go back to the last one? Just. Okay. So again, these are just some of the suggestions from our breakout groups that we had. One of the breakout groups we had. Modeling to comparisons, sensitivity studies. I'm not going to read the whole slide to you. Attribution is a key word today. Just what proportion of the amplification in the Arctic is coming internally as opposed to externally, as I just suggested. And of course, when we talk about linkages, there's been some rather healthy debate as to whether the Arctic is large enough and is thermodynamically and dynamically important enough to have an impact on the middle latitudes as opposed to things coming from a tropical direction. All of these things need more intense modeling studies. Now on to the next slide. So, summing it up, and not to get too repetitive, this is a young area of investigation, and I encourage everyone listening to read more about it and perhaps delve into it. I know some people on the line already actively are doing so. So as Katie said earlier, this report was not one to come up with findings, conclusions, or recommendations. It was more a very timely, hot topic, if you will, one that we thought could bring in a variety of really interesting scientists to discuss the various dimensions of it and kind of give us an idea of the way we may go forward as we begin to look to funding agencies to support future research, look to support future observational and modeling programs. So there's, again, these suggestions: a large-scale research program to understand mechanisms of proposed Arctic linkages, and that tie, I think that very important tie into improved seasonal forecasting. We have to look at this in a picture of a continuum. between seasonal, decadal, and longer term outlooks. Otherwise, I think we'll be missing out on an important way of looking at this problem. We have to look in all directions for mechanisms for Arctic linkages, mentioning the zonality, the stability, moisture changes that have been examined and continue to be examined. The weather and climate communities, as I just alluded to, need to come together to come up with ways of studying this. I might add also the oceanographic community, something we didn't touch on as much in this workshop, but certainly needs, I think, attention in the future. And then impacts, taking it into both the physical impacts and then, I dare say, into societal impacts within the Arctic and beyond. So with that, just want to acknowledge, I'm sure Katie would and has already, our sponsors, National Science Foundation, NASA, and NOAA. It was a tremendous committee to work with. The reviewers did a stellar job. We had just a tremendous group of formal speakers and other participants. And then again, many thanks to Katie and the NRC staff for pulling together what was a really interesting meeting and exchanging all sorts of ideas. And there, I think Katie's already mentioned the additional information that is available to everyone listening and those you might suggest it to. So with that, I don't know if Katie, Luann, you want to add some?
Yes, I'll jump in and say thank you very much, Katie and Dave. I'll point out for our participants that this last slide that's currently showing, I did put a link to this into the chat window, so you don't have to type out those entire URLs to get to these resources they've made available. I also believe that Dave and Katie are both willing to take a few questions. So I'll invite you, if you do have questions or comments, to locate the GoToWebinar control panel and go to the questions pane and you can type it in. And then I'll go ahead and read questions and Dave and Katie can decide who's going to answer them. So we're going to start with one from Richard Heim. He wrote in, is it possible that the atmosphere ocean system has undergone a change in the 1970s, resulting in a change in the basic relationship and teleconnections?
Yeah, Richard, hi. Yeah, I mean, there have also often been some pinning points or transition points that people have pointed out might designate a shift. In my snow cover work, we saw a major shift in spring snow extents in the mid to late 1980s, and then subsequently again in the last decade as you get to May and June. So the question is attribution to those changes. But we have seen, is it a Pacific decadal oscillation? Is it something attributed to increasing greenhouse gases and such? And it's awfully difficult to ferret out those differences. But I think you can't leave anything off the table when you're discussing this issue. So I don't know if that's a complete answer there, but point well made.
All righty, we'll move on to a question from Seshu Vadi. Said, I understand the need for more modeling, but was there any discussion about how well the models currently captured in GCMs address known Arctic processes?
Katie, I know I can't recall we had enough time in our slightly less than 2 days to get into that, but that certainly is a good question, and that is certainly one of the first things that any modeling endeavors are going to need to look at. So I would say there wasn't a lot of discussion that I can recall, but I think everyone would agree that we're coming along. But there's still a ways to go to make sure that the models are handling Arctic processes accurately, completely, and for the right reasons.
Alrighty, we have just one other question in here so far. So if anyone still wants to make comments based on anything you heard or saw, I encourage you to. But this is kind of a question that a lot of speakers or our participants are always interested in hearing our speaker's opinion on. Peter Levely asked, how do you deal with the denial of science, logic, and reason in regard to climate change? It's kind of an open-ended question for either of you to give your bits of wisdom to our participants.
Oh, Katie, you're not going to start answering?
Yeah, I mean, that's a tough one. If people are denying the good science that's being done, I think we just have to keep working at it, keep doing these studies, keep, building up the evidence and hope that reason eventually comes in for at least some.
Yeah, yeah. I mean, I address this both when I speak on the polar work I do, but particularly as I go around New Jersey as state climatologist and talk to people who can be skeptical at times. Although I must say that generally the reception when I speak, and not necessarily when I speak to the choir, but to others as well, is pretty positive, that they understand something is going on and they're looking to understand why it's occurring. Um, I try to treat everyone as an intelligent being and try to see their point or where they have questions. Some come in with a laundry list of questions, and you can only imagine which websites they went to retrieve them. But I approach it from the simple physics of the greenhouse effect, and say that one has to deny physics in many respects, not to understand that changes, the reasons why some changes are occurring. Look at observations, and look at the modeling, and speak to the preponderance of evidence and information out there supporting the fact that climate is changing and humans are playing a major role these days in that regard. But also understanding that there are still holes within our arguments. There's still hypotheses needing better observations and better modeling. And I think if you present it to people in that sense, you're going to reach most people. You're not going to reach the people on either end. And the other end may be some people that say, I'm not excited enough when I talk about these changes. I like to point out that I'm not sitting in my office doing my email. I'm out there talking to them. But I think there's a large contingent of society that just wants to be treated as intelligent individuals, be presented with the information, and helped along in making their own judgments.
And this is Lou Ann Dahlman. I'm going to go ahead and just offer something that I feel positive about. I recently read a brief article in which Admiral Spencer Titley is quoted as saying, people who work in climate change should get ready for catastrophic success. His evidence for this is, look at, would you have believed 10 years ago that same-sex marriage would be legal in, I don't know how many states we have today, but it's one of those things people just didn't believe it would ever happen. And then suddenly the scales tip. And so he was suggesting that that may happen with climate change as well. So I've been trying to imagine what kind of information will people need after those scales begin to tip. And so we may have a large change in how we approach things. And thanks for allowing me to get on the soapbox.
That's very interesting. He's running a nice program now out at Penn State. And there are always interesting things coming out looking at the societal side of things. Yale and George Mason just came out with a study. I admittedly have not read it all, where they look at the terms global warming versus climate change. And they say that most people are lulled to sleep when they hear the term climate change, but their awareness is more heightened when you say global warming. I found that very interesting. I'm still trying to process that, given that my courses are climate change courses. Maybe that's why students go to sleep in them. I don't know.
Looks like the last question that come in is actually a comment, and I bet it's autocorrect sort of thing. Someone's wondering if the storm track slide indicated a paper by Change et al. In 2012. And Denise Hill wondered if it was actually Edmund Chang.
It is. Yeah, that was me.
Sharp eye, Denise. Thank you. Well, I do appreciate everybody's attendance today. And if you do have further questions, something that comes up later on or something, the easiest way to get in touch, I can pass questions on to Katie and Dave. You'll receive a follow-up email, will arrive from Judy Kepsel, and you can reply to that. I would welcome any feedback, further questions, suggestions for topics you'd like to learn about in this webinar series. Comments, complaints, compliments, whatever it takes. And I appreciate you being here on the last business day of May. This will be the end of the webinar session. Thank you very much for attending.
Thank you.
Thank you.